K is gonna be 9 times 10 to the 9th on the test instead of 8.99.
Mm-hmm. 8.999, it will be the same answer. 3, 2. One thing that you guys have been doing really good at is identifying which equation to use. One area for growth that I see, which it can be a little bit confusing, but remember, we have two different K's. We have one big K, which is the dielectric constant, and we have little k. Little k is 9 times 10 to the 9th, or 8.99 times 10 to the 9th. They will give you some equations. Now, electric force, from a scale from 1 to 5, how do you guys feel with Coulomb's law? And I need to see everyone's hand. Coulomb's law, on a scale from 1 to 5, with 5 being really, really good, 1 being I don't know what I'm doing with Coulomb's law.
It's like a version of 4.5.
Okay? Now, for electric field, how do you guys feel? 1 to 5. 1 to 5. Electric field. Okay. And now capacitance, 1 to 5. Okay. A lot less people don't feel super confident, so we're going to spend some time with capacitance today to get you guys really confident with that.
So Bishop,
I'll answer your question when you see Kai.
come on, you see.
Actually, no, stay right here. Kenny's not here yet.
All right, I got a question though. So you were saying like K is 1K is 1 point what? You said K is
There's two K's. There's big K and there's little K.
okay.
Little K is the 8.99 times 10 to the
Right,
9.
yeah, yeah. That's that for that equation right
Yeah, big K is for capacitance, so that's the dielectric constant.
Oh, that's the old. What's the U?
And then U is electric potential energy. So when they ask for work and they ask for energy with capacitors, you want to use U. Remember, each of these U's have, it's an equation. This one has charge and voltage, this one has capacitance and voltage, and this one has charge and capacitance. So each one, this gets the dielectric constant. So typically it's like, and like I said, you guys have done pretty well with electrostatics and identifying which equation to use. Kai can see me go to lunch here today, so I can go over her possibility.
Oh wow. I'm looking up boys at lunch.
Come in here.
Hey, Barry. Alright, yeah.
Alright, so I can begin y'all. Naya. Actually, Ryan, can you come up here for me? You've been doing a really, really good job up front.
I'm not doing it today. I'm just like oh, middle I said. I'm old.
Come on, come in. Ain't no office too. Go get the worksheet back there. We just want to see you writing. Alright, so a positive charge of 1 microcoulomb. That's times 10 to the what?
6.
Negative 6, yep. So a positive charge 1 times 10 to the negative 6 is located in a uniform electric field of 1 times 10 to the 6 newtons per coulomb. A negative charge is brought near enough to the positive charge that the attractive force between the two charges just equals the force of the positive charge due to the field. How close are the two charges? So how close are the two charges? What are we looking for? R. And what do they give us? The first thing that they give us
A positive charge
of what?
1 times 10 to the 6.
So that's what letter?
Q.
Q. Yup. Because it's charged. So 1 times 10 to the negative 6. And then what's the other thing that they give us? Electric field. Great job. I heard a few of you guys say that. So 1 times 10 to the negative 6. All right. Do I have any questions on how I knew those were my knowns and unknowns? What's up, Morgan?
How do we know it's the big Q and not the small Q?
So with these questions, one thing that I like to do when I think about it is look at everything else they give me. And since they didn't give me force, I know it's not little q.
Okay.
So they gave me big Q and they gave me big Q and they gave me
And right, cause we already know K, right? Yeah.
K, yeah. Ooh. Sorry, I wrote that wrong.
Mr. Fisher, what's the one that be not one time thing to -9?
Nano.
He write it in the
Right here.
No, you know with the UC and it means
Okay. So this micro right here means times 10 to the negative 6. Remember, that's micro.
Alright, but which one means to the 9? Remember
Now.
that one? It was another little symbol.
Oh, milli. That's in. Times 10 to the negative 3. Don't get micro and milli mixed up.
That's not what I'm talking about.
Nano's just a little n.
Well, there's no
No,
problem.
times to the 16. You know what I'm talking about now?
Oh, you talking about little, Charlie doesn't want to go on. Times 10 to the negative 19?
Let me come to my head on there.
Okay, alright. So, we're looking for, so we're gonna use the equation E is equal to KQ divided by R squared. So,
Oh, NC? Oh,
Yeah,
that's that's units per Coulomb. That's just units for electric field.
What that mean, like 10 times what?
It's,
you just need little n and big C next to each other, that's nanocoulombs, so times 10 to the negative 9.
That's what I'm talking about.
So, R will be equal to,
little n big C is different from capital N slash capital C.
alright, so, R will be equal to KQ divided by E. You guys see how I got that equation using algebra?
Yeah, thank you.
Alright, good. You guys, your algebra skills have like improved a lot too, I must say.
Thank you.
Said not much, that.
No, I must say.
Say yoga.
Oh my gosh. Alright, 1 times 10 to the negative 6 because that's our charge, but also our field is 1 times 10 to the negative 6. So really, those just cancel out and we can take the square root of 8.99 times 10 to the negative 9, which will give us 94815.6 meters. You guys with me?
Why you laughing?
It's my final answer.
Oh, I was looking for R squared. I was looking for R.
We're just looking for R. Remember, R, I don't know what R squared is. R squared is just the distance squared. I want the distance.
How come mine for the scientific notation?
Say it again.
I had for mine for scientific.
Okay, if you put it in scientific notation, it's like 9.48 times 10 to the, what, fifth? 4?
Yeah.
1, 2, 3, yeah.
No, I'm so fast.
Alright, that was number 1. Raise your hand if you feel pretty comfortable with how we did number 1.
I don't know.
Raise them high so I can see them.
For number 1. I would assume I'm probably.
You guys
doing
over
it.
here, do you feel comfortable with number 1?
Assuming I'm
Okay.
probably doing it.
Awesome. So I'm gonna move on to number 2. So what is the strength and the direction of an electric field 3.74 centimeters on the left-hand side of a 9.1 millicoulomb negative charge? So, looking at this,
It's gonna even make sense. What's megaton on the left side?
that's milli.
She said on the left side.
Oh, yeah, so on the left side. So what this means is we have
Nothing for force.
a charge, and then it's a positive charge, so the field lines go out, and we have something to the left of it.
Okay. So is
That's-
the 9.1 millicoulombs a source charge? Okay.
That's all it's saying. So, what is the strength and the direction of the electric field? So we're looking for the electric field. So, what do they give me in this question? Can someone raise your hand and tell me one thing they give me? Someone other than Mandy.
What was the question?
One of the knowns in this question, one thing that they give me.
Q.
Q.
Go ahead,
Q.
Ty.
I mean E.
But it's big Q.
Ty, what's
Yeah,
one
Q.
thing?
Q.
You give me Q.
9.1 to the.
It's negative 9.1 because
Oh, I'm
it's
sorry. Thank you.
So 9.1 times 10 to the negative 3. Can someone raise their hand and tell me why it's times 10 to the negative 3?
Millie.
Go ahead, Mandy.
Because it's in milli-coulombs. But
Go
but
back.
I was, so it's a test charge, not a source charge. Because I
But-
asked, wasn't a source charge.
But for this question, you have to look at the other things that they give you in the question. So for this one, they give you Q, and they also
I know,
give you.
I asked which Q was it, and you told me it was the big Q just
But
now.
but you have to look at the other
Yo,
things that
DQ
you
is
in the
ready, yo.
question. So if you have other questions, just come see me after class.
You
So,
literally just said it was big Q, that's all I was
electric
asking
field-
about.
the electric field,
Oh, you?
so it says the electric field is 3.74 centimeters. So that means your R is 3.74 centimeters. I need you guys silent back there. Ty, that's why I asked you to move
My
back
fault,
over
my fault,
here.
my fault. All right.
Hold up, is R because of direction?
Oh, because it says it's 3.74 centimeters to the left. You know,
Right.
centimeters is it. So 3.74 centimeters is what in meters?
0.0374 meters.
Yep, 0.0374 meters. And Manny, to go back to your question, that is, so you're looking,
Look, it's fine, maybe I just misread it, okay?
no.
I
wanna
asked you,
answer
was it a
question-
source charge, and you said yes, and then you wrote it as a test charge.
Yeah,
That's all I was
because
asking
So I
about.
misunderstood your question, so this is a test charge,
Okay.
because it's to the left,
Okay.
so, and it's experiencing, so. That's that. Alright, so, it's asking for the electric field. We know that E is equal to,
Yeah, let's see where it says.
KQ over R squared. Oh crap. This is big Q. But,
No. Not money.
I'm sorry, so it's 8.99 times 10 to the 9th. Times 9.1 times 10 to the negative 3 divided by R squared, which is 0.0374 squared. So you guys put this in your calculator and tell me what you get. Sorry about that. I thought this was a different problem.
Okay, sorry.
So she was right.
Yes.
Yeah.
You really got that girl going crazy.
I was right though too.
My apologies, y'all.
Bless you.
I'm thinking like, where's F at? I don't see no F. What you doing? Yeah.
So, what'd y'all get? My test.
You got English and Pacific. Oh, what room we in? What room are we in?
You guys are my room first test.
Great.
Y'all are? I thought I talked to y'all.
Yeah, you are talking.
Yeah.
Who you with?
I have the pleasure of actually proctoring 2 of my classes instead of just 1.
So you proctor this class?
So you guys should have gotten 5.8 times 10 to the 10th.
Shit.
Oh, no, I don't prime you guys, I'm trying for first period, sorry. All right, putting this in our calculator, we get, because some of you guys didn't get this, 8.99 times 10 to the 9th times 9.1 times 10 to the negative 3, and you get this. Then I divide that by 0.0374 squared, and you get 5.8 times 10 to the 10th. Remember, when you guys do this, what you have to do is put the numerator in first in parentheses, and then just divide it by the denominator. Don't try to put it all in your calculator at one time. And make sure you guys put parentheses. All right, can I move on to number 3?
So what's the direction in the chart?
Oh, sorry. So we're talking about a source charge, and it's a negative source charge. So remember, source charges for negatives, do they go in or do they go out?
In.
So towards. So the direction is towards the charge. So
So that would
inward.
be moving
Right.
right?
That's one way to think about it. So moving right.
So hold on.
You know, there's any vocabulary, like real fast, like what is this, yeah, what is it, fine,
Something like, what's the, first one like that was like, as ants see or is. All right, number 3 is our first capacitance question. Yes. Oh, sorry. What's the unit for electric field? I heard someone say it in the back.
Newtons per column?
Newtons per column.
Coulomb. That's a
Coulomb.
column.
Good job.
At least I knew the answer.
All right. An air-filled parallel plate capacitor has plates of area of 2.30 centimeters separated by 1.50 millimeters. The dielectric constant is that little k or big K?
Okay, okay.
Big K is 1.006. Calculate the value of its capacitance. All right. So, looking at this question, what is the first variable that they give us? The area, which is 2.30 centimeters squared. What's the problem with this though? Take a second and stop and think.
it's squared.
Stop and think.
That's all.
All right. Tatiana, what's the problem with this?
Me or her?
Tatiana, Evan.
The units.
It's in centimeters squared. What do we have to get it to?
Meters.
So to go from centimeter to meters, do I divide by 100 or multiply by 100? Divide. 100 centimeters are in 1 meter. But since this is squared, I have to square this entire thing. So what I would get is 2.3 times 10 to the negative 4 meters squared. Ula.
So I just had a question about the formula sheet. It seems we're missing some of the equations.
Oh, yeah, like the
Like
electrical
we don't have
potential.
relation to capacitance, this one is on the absolute value, but we don't have that, and then we're missing the equation.
All right. Really quickly on your equation sheet, because Ula and Mandy brought something to my attention. Right here, is the U equation, the potential energy equation. So electric potential energy is right here. And then the capacitance equations are right here.
I think I changed your V.
So,
Yeah, what's that?
Pi,
oh,
KD.
hold on.
What's your change your
Hell,
V?
Oh, hold on, guys.
I thought we didn't learn
Yeah.
Same.
Not
This is the
Texas.
same equation right here, except for if you get 4 times pi times little k, 4 times pi times little k, it will give you this.
It gives you that.
It gives you this value. This is just the constant. But the thing is, the reason I just gave you that number is because this part is always going to be the same thing. This part right here is always going to give you this number. So instead of having you guys always calculate it, I just gave you that constant off the bat. So you guys not putting your calculator all the time.
Because little k is a constant, so you just multiply it.
Exactly. So I'm going to talk to Mr. Barless and see if I can just have this equation like, I'm going to tell your proctor that to write that on the board probably.
Yo, Proctor.
Why we can't write
What's
it
your
down?
Proctor?
Because we ain't go ahead and pay them. We're not gonna have.
You get a new one for your exam. So don't worry, I'm gonna talk to Mr. Barless, even if I have to go back to your exam text that's already put together and just make copies for y'all.
So it's gonna be like that, not like that.
So it's gonna be like the one I just had up on the thing. Yeah. Don't worry, the equation will still give you the same exact answer. It's just that the equation I gave you is just a simplified version of the equation up there. And that's why the funny shape E isn't on the paper, because the equation doesn't have that.
So the E naught, that's gonna be.
So that was not given to you, but if you put the values inside that equation, you'll still get the same thing. All right, really quickly, so this is area. They give us the distance. The distance is 1.50 millimeters, which is 0.0015 meters. And it gives us big K, which is 1.0006. And then, so I'm not even gonna use the E1. I'm gonna show you that you will still get that value for E. So what was it? 4 times pi times 8.99 times 10 to the 9th. Where's that equation sheet? Oh. Same thing. Because up here, it's in the numerator, the 4 pi k is in the denominator, so I get 1 over that. But if you were to do it, you would still get the same value, 8.85 times 10 to the negative 12. So, looking for capacitance, C is equal to K E naught A divided by D. So I'm just gonna do 1.0006 times 8.85 times 10 to the negative 12 times 2.3 times 10 to the negative 4 divided by 0.0015. So that answer would get me
Oh, you want the hammer test? You got 32? That's what it
this is 2 point. This is 2
So
point.
what's your name at night?
1.35 times 10 to the negative 12. Farads. Remember the unit is a farad. I just did it the other way. And when I did the other way, you guys see I did 4 pi times 8.99 times 10 to the 9th, and I still got the same exact answer. So no matter which way you use, you still get the same answer. Because 3/9 is in the numerator, and then the 4 pi over that's in the denominator. So 1 over.
Yeah, but that's still not, so how can something that's not the same, something that's not in the denominator be the same
4
thing?
pi k is 1 over 4 pi k.
Oh, 1 over that. Oh, okay, so E naught is the reciprocal of that. Okay. Alright, cool.
Oh, is that formula right there? No, I'm talking about E. That E right there is energy. Yeah, those 3 equations, that's it.
All right, thumbs up if you got this same answer for capacitance. I need to see everyone's thumbs, and thumbs down if you don't, but I need to see everyone's thumbs. And sideways if you want me to come over and check something for you. All right, good job. And like I said, I just talked to Mr. Marinelli. I'm going to let your faculty know about the equation changes so you guys have the equations that I give you too. All right, you guys can back up.